Hi y'all, this is Unit 3, Lesson 1, Investigation 1. Okay, we're going to be doing modeling linear relationships. So you should have already done the think about the situation in class. Let's go over those answers really quick. Okay, if you looked at letter A, you should have said something like, for every 2 applications, his pay increased by $10. Okay. Letter B, if you had 1 application, it was $25. 13 applications, it was $85. And 25 applications should have been somewhere in that $145 range. Don't worry too much if you were slightly off, but you should have had somewhere in that general vicinity. Okay. And again, same thing on letter C if you had no idea what they were asking, right? They did give you a clue back here that we were going to be writing linear equations in the form of y equals a plus bx. Okay. In this case, the a, the constant would have been 20, that was where we were starting, and then the plus 5x represents the slope. But again, if you don't understand that now, just by the end of the unit, we want to make sure we're clear on that. Okay. So if you didn't already, please read through the problems, okay, and try them out on your own. Okay. Number 1 is a continuation of the credit card problem. Let me zoom in here. So letter A, there are the table values. You should have had, if there were no applications, you had $20. There's the 1 for 25. 2 applications, $30. 3 applications, $35. 4 applications, $40. Remember the 0, the 2, and the 40, those were all given on the chart. So you had to make guesses on the middle. And once you knew that this was increasing by 10, every time this was increasing by 2, if you cut both of those in half and go up by 5, you'd just be increasing by 1. Okay, so that continued on through here. Now when you got to 10, 20, and 50, you had to be a little creative. Okay, 10 you should have gotten up to 70. You could use the chart. 20 was 120, and 50 was 270. Okay, if you use the chart for some of those, that might have helped. Over here, let's look through the answers on B through E. B was asking you to compare the pattern of change shown in your table with that shown in the graph, right? So we said for every new application, the daily pay increased by $5. So previously we had said for every $10 in pay, it increased by 2 applications. So we're just reducing that down essentially. Okay. Letter C asked about when there were no applications, right? It was $20. And we knew that using the rule, that would have been when n equaled 0. Right? Looking at the graph, that would have been what we call the y-intercept. Really important that you get that vocabulary down, right? That's where you're crossing the y-axis in the graph. Letter D was similar. Given the rule 20 plus 5n, the $5 was the amount we were increasing each time, right? And that was the number in front of the n. Graphically, though, that will represent the slope of the line. Again, slope and y-intercept, 2 key important vocabulary words for this section. And then letter E, they asked you to write a now-next equation. So the next term would always equal 5 plus the previous term, or the now. And remember, with your now-next, you need to mention where you were starting. So starting at 20. Because that was if you had no applications, we were up at $20. Okay. Again, if you haven't already done so, please read through number 2. Number 2 was about Sherry at the same credit card company, right? And we wanted to see if what her data was saying. So letter A asked, does Sherry's daily pay appear to be linear? And when I looked at the chart, which I know is kind of off the screen here, I said yes, it appears to be linear because for every $10 increase in services sold, right, there was $20 increase in pay. So remember, linear will be where you're at a constant rate of change. It's changing constantly the entire time. Okay. Now, if you struggle with filling in the table on B, you may want to jump to C, try that out first, and then jump back to B and see if you can figure out the table. But the correct answers for the table on B, let's see if I can make this a little bit bigger. You should have had those values. So you had the 60, 80, 100, 120, 140. The ones that went in between, 0 should have been at 40, 15 at 70, 25 is 90, 100 should have been 240, and 101 should have been 242. Okay. Now for the table down here, again, this is where it might have made more sense to fill this out and figure this out before you went back to the table. Okay. This was saying this is the change in sales from 10 to 20, 20 to 25, 25 to 40, 50 to 100. And notice I put a little number in here, right? Maybe think about what that number is representing. And that number is representing the difference. Going from 10 to 20 was a difference of 10. right? 20 to 25 is a difference of 5. 25 to 40 is a difference of 15. And 50 to 100 is a difference of 50. Okay? So the change in pay each time, if you look at the chart, we're going up by 20, up by 10, up by 30, and up by 100. Okay? And if you look at that, if we're looking at the rate of change in dollars per sale, if you take the change in pay and divide it by the change in sales, that will result in your rate of change. So if we take this number divided by that number, if you notice, right, you should have noticed a pattern. It was constantly $2, right? And so no matter how much you're increasing on a table, if you're going up by a certain amount, if you look at how much you were going over each time, that will result in the exact same rate of change, which is $2. Okay? So that's going to be really important if you look at your letter D, the now next, and letter E, the rule, right? Notice letter D, the now next equation, we'd say the next term would always equal the now term, wherever we are right now, and we would add 2 to it. Okay? And that was starting at 40. But realize, if you're going to be looking at it from a formula point of view, and that's what letter E was asking you to do, was consider the following rules. Which of the rules will calculate Sherry's daily pay C for any number of services she sells? Right? You should have picked number 3, right? This was 40, that's where we were starting, plus 2N, right? The starting point is $40, and it increased every $2 per sale. So that's represented by the 2 here. Okay. Remember, if you have any questions on this as you go through it, write it down so we can go through it tomorrow. Okay. Last but not least here, number 3, they gave you a picture of 3 different banks, right? We have the Atlantic Bank, the Boston Bank, and the Consumers Bank, right? And they gave you these 3 formulas, and you need to match up which one was which. Okay? Hopefully you should have noticed that 2 of the lines started right here, and only 1 of the lines started here. Okay? And that will be the constant. So because these 2 shared a 20 and this one had a 40, you know that these 2 had to be the one with the 20, and that this one had to be the 40. So I know that number 2 should have been letter C. And then it's a matter of figuring out which one was the steeper line and which line wasn't as steep. Okay? And that goes back up to Atlantic Bank and Boston Bank. If you look at 20 for both of them, one has a 2 out in front and one has a 5 out in front. That will affect the slope. Okay? So whichever one's steeper will have the steeper slope. So that's why I know that B was graph 1 and number 3 was graph A. So we can compare the slopes. Okay? So letter A should have been 3, B should have been 1, and C should have been 2. Okay? And then matching the formula for letter B, the Atlantic Bank was 20 plus 2N. So making sense of that, we were starting at $20, right? And then 2N, we were getting $2 per sale. Okay? I'm going to cut that off here. Just problems 1 through 3 you're responsible for today. Any questions we'll discuss in class tomorrow, okay?